This is our third video on math review. This time we will talk about vectors. Why vectors? Because many quantities in physics are vectors. Acceleration is a vector. Velocity is a vector. Force is a vector. And position of the object is also a vector. First of all, let's agree on notations. What is a vector? It has magnitude and direction. So if I write a letter and I put this arrow above, I mean a vector. If I don't put an arrow, if I do something like this, or I do something like this, both stay for magnitude. Magnitude, that's how I will denote magnitude. What is magnitude? It is just length of the vector that we measure with the ruler. We can measure with the ruler. Magnitude. Okay, so the goal of the video is to refresh or to learn how to write a vector in terms of components in a given coordinate system. In other words, how to write a vector in terms of unit vectors, or how to find components of a vector in a given coordinate system. So I will have vector r. This is my vector r. And we understand that this vector r is a vector sum of two vectors. This is vector A, and this is vector B. Vector B. We know the rule. If I have A plus B, A as a vector plus B as a vector, then the vector sum is from start to tail, it's R. We know that. I will also introduce, this is 90 degrees, this is my favorite right triangle, and I will also introduce angle theta that R makes with horizontal. What's next? Next, we will introduce or refresh unit vectors. What are unit vectors? I will write it here. If I have a coordinate system, this is my x, and this is my y, then unit vector I, by definition, is along x. In different books, I is called differently in many math books. This symbol is used to denote a unit vector, which is perfectly fine. I will use this arrow for everything when I mean a vector. But what is special about unit vector? I is a unit vector. Oh, you probably already guessed, even if you didn't know that. Magnitude of I, by definition is 1. So we measure this length of I, it's always 1. And by definition, I is along x, always. We introduce one more unit vector, vector j. What is, no, it doesn't work. I will use pink again. I will introduce unit vector j. This distance is the same as this. Do you see it? If not, have imagination. Unit vector j. What's special about j? It's unit vector. So what's magnitude of j? Magnitude of j is 1. Length of vector j is 1. And by definition, it is always along y. So I bring these two vectors here. Unit vector I and unit vector j. Oh, I forgot arrow. I and j. Now I will write vector A in terms of unit vectors. So what is vector A? Magnitude of A is just, let's call it A, length. What is this? 5 centimeters. Great. And the direction is along x. So I put a unit vector here. We know what we are doing. So magnitude and the direction, for the direction I use unit vector, it doesn't spoil magnitude because magnitude of I is 1. What about B? Now we write B. Where is B? Here. Magnitude is just B, length. And then direction is along y. I show the direction with my unit vector. So now what is vector R? Vector R, since it is A plus B, it is at the same time A is AI plus BJ, and everything that I have in front of unit vector I is called X component of vector R. And the guy that is in front of J is called Y component of vector R, R sub Y. Any vector could be written in terms of components as R sub X I plus R sub Y J, where R sub X in this case is A and R sub Y is B. The next problem that we need to solve, and this is the problem that we will do in physics over and over again. What if the length of R is given and theta is given? Let's find X and Y components of R. If A and B are not given, we need to find them. And that will be our next problem. For our next problem, R and theta are given. We want to break vector R. We want to write vector R in terms of components in a given coordinate system. So I again have a unit vector I and unit vector J. And step number one, I need my right triangle. So which triangle do I like? I will draw a line that is perpendicular to X, and this is my right triangle. Now, I know that any vector could be written as R sub Xi plus R sub Yj. The question is, what is R sub X and R sub Y? Since I already have my right triangle that I like, I immediately understand that, okay, vector R is a vector sum of this vector plus this vector. Now, what is this? The length of this vector, the length of this leg is hypotenuse R times cosine of adjacent angle. And then I have this I for the direction. What is R sub Y? R sub Y in this case, so this vector is up, it is along Y, so it is plus J here. What is the length? What is the length of this vector? It is R times sine theta. We did it. We found both components of vector R in a given coordinate system when R, magnitude of R was given, and R was at angle theta with horizontal. Now let's do a little bit different problem. And I want you now to pause this video and to solve the next problem on your own. So this is X, this is Y. In this case, this will be my vector R. And again, I give you the length of this vector, which is R. And this R has, let's see, why don't we go, no, let's have the same so far. And it has angle theta with horizontal. So R and theta are given. Please write vector R in terms of components. So any vector could be written as Rxi plus Ryj. The question is, what is R sub X and what is R sub Y? So please pause the video, solve the problem, and we will compare our notes in a minute. Are you back? Then let's compare our notes. What I would do, I would find my favorite right triangle. In this case, I just draw a line perpendicular to X, and this is my right triangle. Next, I understand that this vector R is a vector sum of this vector plus that vector. Do you understand that? Yes. So what is r sub x? First of all, this vector is the length. Let's talk about magnitude. The magnitude of this leg is hypotenuse r times cosine of adjacent angle, but the direction of this vector is against positive direction of x or against unit vector r. I put minus I here to indicate the direction. I'm done with this guy. Plus ry. What is ry? It is up. The length is r times sine theta and plus j. So I factor out this minus r cosine theta I plus r sine theta j. And we know that everything that is in front of I is r sub x. And this guy in front of j is r sub y. Problem solved. What is r sub x? The projection of this vector r on x is negative. It is minus r cosine theta. The projection of r on y is positive. It is plus r sine theta. We did it. How else can you think about it? If you take vector r and you bring it along x using the smallest angle, you immediately see that, yes, it is along negative direction of x, which means that projection of vector r on x is negative. Keep track of these signs. The last note that I want to make is imagine now that instead of r and theta, the components are given, r sub x and r sub y. If the components of the vector are given, how to find magnitude and direction? So since this is r sub x and this is r sub y, to find magnitude of r, we just use Pythagorean theorem. What is r squared? R squared is rx squared plus ry squared. And this is magnitude of the resultant of vector r. And again, if r sub x and r sub y are given, how to find angle? We know what to do. Tangent theta will be equal to ry opposite to adjacent. Could be positive, could be negative, depends on the sign of projection of y and x. And the next problem that I will put here, the only difference will be just different position of r. Please stay with me for one more example, and we will be solid on vectors. For our next example, I will just change what is given. Instead of this vector r, let's have this vector r given. This will be my vector r. The length will be magnitude of the vector will be r, and it is given. And this vector r will make angle theta with vertical. Angle theta with vertical. R and theta are given. The task is the same. Let's write vector r in terms of components or in terms of unit vector. Or let's find the projections of vector r on x and y. You can pause the video and do it yourself, and I'll just keep going. So, what's step number one? I know that any vector could be written as r sub xi plus r sub yj, and what I need to do, I need to find each of these components. So don't look here, this will be changed. Don't look, don't look, don't look. Step number one, I need to figure out my right triangle. I draw a line. Which line, which right triangle do you like? Your choice. I like this one. Is it too small? Let me enlarge it. I'll make it bigger for you to see it. This is my r. Oh, this is my r. This is my theta. And triangle that I will like will be, it's not horizontal, will be this one. Is it better? You like it? Okay, let's keep going. This is 90 degrees, 90 degrees. Now, The task is the same. I need to find x and y projections, so right triangle is right here. What do? We understand that this vector r is a vector sum of two vectors. This vector plus this vector. Okay? Or in other words, if I take r and I bring it along y using smallest angle, it will be along negative y. So, what do? I skip this step when I wrote minus I. I will factor it out, minus I or minus j. I will factor sign immediately for this problem. And that's what I hope you will be doing when you solve physics problems. So, question. Is Rx, x component, positive or negative? So, is it plus I or minus I here? It is plus I. X component is to the right. So, what is R sub x? First of all, we put length, magnitude. It is r. In this case, theta is opposite to this leg. So I put r sine theta and plus I. We are happy. And this is my r sub x. What is r sub y? Positive or negative? I put plus. This is this plus, but then I will open parentheses. Why? Because I want to emphasize, okay, so this is ry. It is along negative j, so here will be minus j. I factor it out. Minus hypotenuse r times cosine of adjacent angle for this leg will give me the length of this leg, which will be r, and then cosine theta. J. I already took into account my minus. And you know what? What is this? Everything that is in front of j is r sub y. So we now know r sub x, which is r sine theta, and r sub y, which is minus r cosine theta. Problem solved. We wrote r in terms of components or in terms of unit vectors, or we found the components of r in x and in given x and y coordinate system. All right, the last thing that we need to know before we start doing physics problems. Every time I promise, I thank you that this will be the last, that we really need to know how to add vectors. How do we add vectors? So next example will be on vector addition, and then we will be ready for our first kinematics video. If I have two vectors, vector r1, and I write it in terms of components, r1x, unit vector I, plus r1y, unit vector j. And I have vector r2, which is r2x, this is x component of r2, plus r2yj. How to find the resultant r, that is r1 plus r2? How to do that? I switch color because my marker started singing. So r1, let's just rewrite it. r1xi plus r1yj, and then plus r2xi plus r2yj. What I'll do next, I will factor out I and I will factor out j. Let's combine these guys. So what is with I? What do I have with vector I? I have r1x plus r2x, unit vector I. I cannot skip this unit vector I because this is in x direction. And then let's do it for j. J, I have r1y plus r2yj. And at the same time, I know that vector r could be written, this vector r could be written in terms of components as rxi plus ryj. So what do we do? To find x and y component of the resultant, we just add x and y components of both vectors. What is r sub x? X component of the resultant, it is r1x plus r2x, and I remind you that each of these components could be positive or negative. It depends, as we saw in our previous examples. And what is r sub y? Again, we add y components to find y component of the resultant. r1y plus r2y. And I believe that's all we need to know to solve problems, physics problems.